Thank you, everyone. Warm welcome to today's session and webinar on container adaptation and its strengths for Agile app development. Yes, as you all know, the era of computers ever since it has born, there had been drastic, uh, uh, drastic scientific development that has happened. It went on to small computers to a large scale code processing machines. Then the era of virtualization started, where predominant virtualization players like KVM, Citrix, VMware, all of these players started coming in. So virtualization was prominent in the 20s era. Now, after virtualization, it eventually gotten into software-defined data center to a turnkey, to turnkey solutions. Now, the current in the era of digital transformation, currently, virtualization has really become very fat. It's not so much provides agility, whereas containers, as you know, containers in the current era provides real agility. It is not so fat. You can boot it quickly. You can deploy your applications. It enables portability, and these are the different benefits what containers as such offers, right? So if you look at it, digital means most of the customers now things as microservices, and microservices obviously containers becomes the best platform of choice as the underlying infrastructure, right? So hence today's session is in this current generation of digital transformation. Microservices and containers becomes a best trend. So today we are going to talk about the container adoption and its trends in the market. So as I was talking to you, uh, the best platform for the deployment of the containers for the microservices is containers. And architecturally, customers or the world is moving towards from monolithic applications to containerized microservices application based architecture. What it means, the cloud native or 12 factor microservices architectural style becomes the most prominent architectural pattern that's utilized throughout the world, and containers play a critical role. So Kubernetes obviously is the choice for orchestrating the containers, be it as the on-premise environment or on the multi-cloud environment. So containers are really gaining very heavy popularity in that way that it provides seamless portability. The complete it heavily helps to improvise the productivity of developers, and more importantly the ease of management and high service availability, right? You can start managing containers. The platform Kubernetes by itself orchestrates and manages the containers and it automatically self-scales, right? And now the latest in the 5G and the edge computing world and the IoT, containers are really becoming a more prominent platform of choice. Imagine you have edge computing nodes residing in each and every of your apartment buildings, where the contents are being delivered very closer to the user network, right? That's the edge computing all about, where the entire telco and the 5G radical change is happening in the architecture, and containers becomes the best platform of choice for the telcos and 5G world to push your specific applications near to the customer's location, or even if it's an industrial adoption and automation, from a centralized core network in the telco, you can push all your edge related applications closer to the customer or closer to the specific industrial automation area at the edge as containerized applications. So containers are easy to manage, and containers are there everywhere, right? And as per Gartner's prediction, by 2022, 75% of the organizations will be completely running in containerized world. So it means there is a big business, and there is a radical change in the complete IT architectural style itself, powered by containers. So now let's see who are the prominent container or the Kubernetes platforms in the market, right? Uh, so VMware has launched a specific portfolio called Modern Applications Platform, or a BU. VMware provides VMware Tanzu. Tanzu, specifically for modern application, comprises of various products, and the erstwhile Pivotal Cloud Foundry is merged into the Pivotal is acquired by VMware, and it's merged into the Tanzu portfolio. Tanzu offers your open source based upstream Kubernetes engine for containerized applications deployment. It also has an enterprise grade platform as well. So prominently there are two variants: Tanzu Kubernetes Grid and Tanzu Kubernetes Services. Right? And so that's one of the product. The other product and the platform in the market are you have OpenShift. OpenShift has got a community edition and as well as the enterprise version supported by Red Hat. And as you know, Red Hat and IBM being merged, Red Hat hasn't been taken over by IBM. IBM had its own product called IBM Cloud Private, which is ICP. Is now IBM has started taking OpenShift as their strategy, and OpenShift is a go-to platform for all for containerized applications deployment. Having said that, IBM has got other value-added components on to over and above OpenShift for you to deploy your platforms across multi-cloud. And even Tanzu can be deployed even on your on-prem or in your even in an IoT or an edge based. Say for example, if you have a Raspberry Pi, you can even deploy a Kubernetes on top of it, right? Across on-prem as well as on multiple clouds, both Tanzu and OpenShift can be deployed. And some of the cloud providers provide cloud native Kubernetes services. Example, Azure offers Azure Kubernetes services, and AWS offers EKS, which is Elastic Kubernetes Services, and Google offers Google Kubernetes Engine. And again, while Google Kubernetes Engine can be deployed on Google the Google Cloud, it is now available for you to deploy on-prem, and you can deploy Google Kubernetes Engine on AWS. And in the roadmap, they do have to deploy Google Kubernetes Engine on Azure Kubernetes Services itself, right? And on the open source front, the two major players are SUSE, which is a open source, open source enterprise grade open source vendor, as like Red Hat. SUSE offers SUSE CAS platform. Recently, Rancher had been acquired by SUSE, which is another open source based container Kubernetes engine. Well, there are other startup ecosystems like Kubernetes and other Cube 360 and other startup vendor players are there in the market. These are the prominent enterprise grade vendors who are there. And Kubernetes is one of the leading open source based other player, from a startup ecosystem perspective is coming up well, right? So in a nutshell, Azure Kubernetes Services, EKS are very cloud native and cloud specific providers, right? Of course, you can have Azure Stack on the prem and you can have AWS Outpost. You can have the Kubernetes services as well. But really, from a vendor agnostic standpoint perspective, VMware Tanzu can be deployed across on-prem or on any cloud, and OpenShift can be deployed across on-prem as well as across any cloud. And you have Google Kubernetes Engine, which can be deployed on-prem as well as on Google Kubernetes Engine can be deployed on-prem as well as on multi-cloud. At the moment, you can deploy it on Google and EKS and other platforms. SUSE and Rancher can also be deployed on-prem as well as on public clouds. So these are the prominent players in the market which are being prominently used by various customers. So now, if you look at customers, the tier 1 financial services and retailers, customers are really moving towards the adoption of different Kubernetes platforms for different applications or workloads. Example, if you take a core banking say for an example, let's take an example of Oracle Finacle, right? Oracle FlexCube, which is a core banking platform. Oracle FlexCube works very well with Oracle Container Platform, right? Oracle Kubernetes Engine. Whereas customers are more and more wanting to have, which is a core banking platform at the back office, and customers prefer cloud as their digital transformation platform in terms of hosting their front office applications, right? So it is the nature of the applications, be it as the core banking or the core retail or the core supply chains, where customers are very data pervasive and data conservative, doesn't want to go to the cloud to move these data privacy or conservative applications to retain it on the prem, and the set of applications demands specific Kubernetes engines, right? And whereas digital transformation, customer experience led applications of from a front office perspective, it's more and more hosted on the cloud. Having said this, so customers always tend to have heterogeneous Kubernetes platforms for their enterprise, with certain Kubernetes engines on the prem and cloud native Kubernetes engines on the cloud. So your IT operations becomes very, very complicated, and IT development is being done by different polyglot cloud native applications, starting from Java, Node.js, Ruby, Ruby on Rails, Python, right? CIO start adopting a model of cloud native application architectural style. Gone are the days of choosing a particular technology like a Java or specifically a .NET. Now customers start adopting more and more cloud native architectural style paradigm, wherein they can handpick any developer on the floor, and with developers' choice of language, wherein they wanted to do the microservices development, and cloud native architectural style becomes a glue across these any kind of platforms to integrate all these microservices together, right? So your IT development is also becoming very complicated because of these heterogeneous wide variety of languages, and IT ops is also becoming complicated, whereas the business demands agility. How does IT meets the demands of the business agility, right? So here comes the latest trend, which is coming up, is a hybrid multi-cloud, multi-cluster management layer, which glues all these heterogeneous layers together and becomes one single abstraction layer, so that you don't have to run around or bother about the operations of all these different cloud providers and technology or development platforms. Right? What it essentially means is it empowers you. This abstraction layer empowers you to become a cloud of clouds, or the father of all clouds, right? So you can have Kubernetes running on-prem, as well as you can have Kubernetes running on any of the public clouds. This abstraction layer, provides a single pane of glass, or consistent user interface, consistent operations across on-prem as well as on the cloud. Say, for example, it unlocks the vendor lock-in, right? That you get with any of the particular vendor-specific Kubernetes provider or container platform providers, or it unlocks the vendor lock-in with any of the cloud providers itself. So today you can get started with, say for example, an on-prem virtualization stack and deploy Kubernetes on top of it. It could be a VMware or an OpenStack, or it could be even a plain bare metal. And tomorrow you want to move on to the cloud, be it as Azure, AWS, or Google. Right, this abstraction layer helps you to seamlessly move your applications from on-prem to the cloud. Right, it enables seamless workload mobility. More importantly, it enables cloud portability or application portability from between on-prem versus cloud, or from one cloud provider to the other cloud provider. It also enables interoperability between cloud providers via this abstraction management layer, and provides business continuity in terms of unlocking the vendor lock-in and the ability to move your workload from on-prem to the cloud or between cloud providers, right? So that's this abstraction layer, which is actually a multi-cluster management platform provided by various platform vendors. This has become one of a key important trend in the market. Multi-cluster management layer, that is an abstraction layer which abstracts all of the complexities of any underlying Kubernetes providers, becomes the latest trend, right? So this is a typical capabilities of the abstraction management layer, or the features that are expected out of this platform in order to manage your microservices and containerized workload, involves, say for example, a self-service layer, where you can log into this abstract management single pane of glass user interface layer, and then provision any Kubernetes of cluster of your choice, or you can manage all of these Kubernetes clusters in a single pane of glass, right? So the abstract management layer, say for example, you want to spin off a VMware Tanzu Kubernetes grid, or you want to spin off a OpenShift, or you want to spin off a AKS or a EKS. Log into this platform, click on a button, and say point it to your hyperscaler as VMware or OpenStack, and say I want to spin off a Kubernetes engine with 3 master, 5 worker nodes, and in this particular VPC or a network or subnetwork, and then click on a button. It is going to spin up the Kubernetes engine for you. Imagine how simple and nimble life is. Earlier, if you have to spin up your own your cloud, your Kubernetes provider specific example of OpenShift or a VMware Kubernetes or a Rancher, you need to spin up the required underlying VMs, go and deploy all those bits, set up the container networking, set up the container security, and it was so every provider has their own mechanism of provisioning their engines, right? So when customers are embarking on hybrid multi-cloud digital transformation journey, it really matters a lot. You need to have a multi-skill, but this abstraction layer, helps you not to depend on multi-skill or Kubernetes provider specific way. Abstracts all of that complexities and provides a single pane of glass or a consistent user interface by which consistent operations, by which you can seamlessly work and operate across any container management or any container platform providers, right? So that's the agility, or that's the operational efficiency, and from a skill perspective, consistent skill set that this abstract management layer provides to you. So the next thing is application lifecycle management. So the entire developer community starts learning this new style because of the container adoption. Starts has completely learning all about the Kubernetes. Example, to deploy a container application, you need to know about part spec, deployment spec, service spec, and if there is any ingress, and your role-based access controls, your definition of storage classes, your storage definitions of config maps, and persistent volume claims, and so on and so forth, right? So the entire developer community, rather than focusing on the business logic, starts adapting and learning this Kubernetes infrastructure as a code, right? Is there a way that I can do any traditional way of application deployment, wherein I go ahead and choose my application code base, and there has to be a platform that would automatically, since it's a Java code or a .NET code, right, and builds the application, post application build, it automatically generates a Kubernetes, all the deployment descriptors, right? So as part of my application code, I would have a pom.yaml, or I would have a Gradle YAML files, or the for .NET or a Node.js package JSONs and everything in place. So the tool takes those build related instruction and builds your application and generates a binary, and the build also has instructions in terms of how many number of replicas or how many number of instances of the application, and what would be the port at which the service has to be exposed. The tool automatically, or the abstraction layer automatically generates all the YAML files for you. Now the life of the developer becomes so easy, as like the traditional days, that the developer starts focusing only on the application code or the business logic, right from generating the container containerized image, and generating the Kubernetes YAML files, and everything becomes in an automated fashion, right? So that has become the latest trends. Apart from the containerization, right? How operationally we can make transform, or operate, how do we transform my enterprise from the traditional monolithic world into a quick containerized world quickly, right? Rather than my entire developer community going through a radical change. So this is a very important feature, or a trend that's it's prominent in the market, that the data lifecycle management, protecting your data. The traditional data production methodologies are very heavy. Example, let's say you have a 10-node Kubernetes cluster, and each node have a 1 TB of disks, right? If you have to back it up, you have to back up the entire 10 TB. Is it really required? Probably the operating system is there, and there are a lot of stateless applications is there, because all the Kubernetes state is there. The application deployment is there in terms of Kubernetes YAML file. So really, do we need to just back up the entire underlying data, which is not required, right? So all you need to do is you just need to back up and require only the persistent volumes, only the stateful applications that you have to back up, recover, clone, right? You don't require the entire 1 TB of data, right? So if you need to recover the applications, all you need to do is bring up a new Kubernetes cluster from the cluster lifecycle management single pane of glass and repoint your CI/CD pipelines to go ahead and deployment, right? But for stateful applications, you just need to back up only the particular persistent volumes, right? You don't need to back up the entire underlying storage of 1 TB of data, which includes operating systems, Kubernetes bits, and so on and so forth, right? So that's this advanced, intelligent way of doing data production, right? There are various tools in the market. There are various open source tools and vendor products that are available in the market that does this intelligent way of data production. The next thing is centralized monitoring and logging and auditing. Imagine when you are going through this digital transformation, you have hundreds of Kubernetes cluster. How am I going to monitor all of them in a single view, right? The various open source based tools in the market like Prometheus, Grafana, Jagger, Kali, all of them provides you can go ahead and deploy into a particular Kubernetes cluster, and you can have monitor that particular Kubernetes cluster. But what if I want to have a single one pane of glass where I want to see all the state and metrics of all the 100 plus Kubernetes clusters in a single pane of glass, and I want to see how the clusters are doing and what is their health check and how are they doing from an overall disk memory and CPU pressure, right? That's the centralized monitoring and logging functionality from a multi-cluster or a multi-cloud management perspective. Then seamless workload mobility perspective, right? What do you mean? Let's say if you have a cluster on the prem OpenShift and you want to migrate to OpenShift on the cloud, right? How do I click on a button and then move your workload, right? Or let's say if you are on Google Kubernetes engine on Google Cloud and you want to move on to the Google Kubernetes engine on AWS, right? How do I click on a button and move my workload, right? So that's the seamless workload mobility. Rather than doing an entire data migration, the seamless workload mobility is a feature that helps customers to move on, right? And migrating VMs to containers. So this is actually a very good trend in the market that CIOs can start adopting this, right? Rather than going through a 3-year-long digital transformation in terms of migrating all my monolithic applications to microservices and in-turn containers, is there a way that I can lift shift automatically all my VMs to containers, right? So isn't it really interesting? Or run the VMs as if containers. No more hypervisors are required. Take a platform like OpenShift, right, where use open source based projects. There are projects like KubeBird, right, like a LibBird. You have KubeBird, by which you can run your VMs as containers, right, where your Kubernetes engine orchestrates the container high availability, right, like the typical hypervisor which does that functionality, right? So that's where the Kubernetes has evolved very heavily. Then there are container optimization and billing and showback and chargeback functionality. When you adopt containers, let's say you have a huge 10 node cluster, how do you show back? How do you know what is the billing that's happening? How much is per application cost consumption out of the Kubernetes cluster? How much is the namespace level cost consumption out of the Kubernetes cluster? The next important functionality is the centralized network and security and policy management. I have a huge 100 Kubernetes cluster, and I have a 1,000-member IT team. Who will have access to what? Which cluster? So the role-based access control really need to be centralized. If you look at Kubernetes currently, it focuses very heavily on a single Kubernetes engine where you define your cluster role, and role-based access controls. You create YAML files, right? But you have to go and execute it against each and every Kubernetes cluster. Is there a way that I can actually centralize all of them and define all my users in my enterprise, and those enterprise roles are seamlessly being pushed to all the Kubernetes clusters. And I can group the clusters and say for example, production clusters, need to have access to only to the prod administrators, not for developers, right? And in the development environment, developers should have even Kubernetes, cluster administrator role, right? And not in the system integration or in the quality testing environment, right? So that kind of a sophistication at a centralized level can be done by this. So there are various. This is actually has become the latest trend, and this multi-cluster management becomes a key trend and an adoption in the market. So here is a view and glimpse of various multi-cluster management products that are available in the market, which can actually orchestrate across any of these platforms, across these platforms. Then finally, it is not just Kubernetes, right? When you are embarking on a digital transformation, it is not just Kubernetes. You need container storage, container networking, microservices management, and container security, logging, API gateway, application performance monitoring, identity. You require an end-to-end integrated ecosystem, right? That's this multi-cluster management or a multi-cluster container management platform, which is the latest trend that's available in the market. And it brings heavy automation in terms of automating the cluster and app lifecycle management. The erstwhile for a typical Kubernetes cluster provisioning and application development of an application which takes 5 days, but this multi-cluster management layer brings 20x faster efficiency, right? And here is the traditional app containerization, application containerization steps that are being followed. Typically, we assess the application, and based on the application, we write the Docker files, and we create the application and web services images. Images from the Docker file, and we define the Kubernetes YAML files to deploy the applications into the target Kubernetes platforms, which can be automated via the DevSecOps platforms and tools that are available in the market. And finally, customers tend to in the containerization process, they not just the containers they tend to do, they even transform the middlewares. Right. Example, say for example, you have a robust monolithic WebSphere or an Oracle WebLogic server, right, running, which they can be containerized. Not just the application servers, your enterprise services, messaging server, messaging queuing platforms, your API gateways, all of them can be containerized and deployed. So, right? So it's not about just app containerization. Even the integration layer and middlewares can be, containerized to either open source or even the COTS platforms containerized. With that said, that's all I have. Happy to take questions offline. Keep me posted. Right. Thank you very much for providing this opportunity. And to finally a notice, in the era of digital transformation, by 2022, as Gartner predicted, 75% of the organization will be completely running on, will be running as containerized applications. So there is a huge potential, and there is a radical change in the application development and the architectural style that's happening. And containers and Kubernetes becomes the best platform of choice. That's all I have for this session. Thank you for providing this opportunity.
Thank you, sir, for such a wonderful session. And can we now take the questions quickly? So if you guys have any question, you can ask here.
Sir, here is one question on how to secure it is to use the cloud to store data. Can you answer that?
How to secure? Can you repeat your question? How to secure?
Yeah. How secure it is to use the cloud to store data?
Okay. So there are various. So there is a data security, and there is a network security. There is app security, right? So there are various tools in the market, but cloud native security itself provides, right? Example, cloud native security the tools available as part of the cloud providers, and there are various third-party tools that are available available in the market as well. Very specifically, when it comes to the data, example, let's say if you are storing the data in a S3 bucket, cloud platform itself provides mechanisms by which it has, or if you are storing your data on an underlying VM, say for example on an elastic block store or on a persistent disk on right. So the cloud providers gives you a mechanism by which you can encrypt the data, and you have database security that are available for data at rest and data at motion, as well as both from application standpoint, from an operator perspective, from operations perspective, as well as from applications perspective. So in a nutshell, there are cloud native tools available that would help you to protect the data at rest, and as well as the data in motion. And there are third-party products available in the market.
Thank you, sir. There is one more question from Mr. Manjunath. It is, how can we minimize cost when we need to run multiple clusters for management?
That's a very good question, right? That's actually a typical problem that's happening in the current market. Multi-skills has become a very huge cost. It's very tough to find a skill set who is an expert of all. OpenShift or AKS, EKS, Google Kubernetes Engine, and all of it, right? So you need to have multi-skill. So cost becomes increasing, and also each of these Kubernetes comes up with its own operations, right? So both development and operations, both from skill perspective and day one and day two operations perspective, it incurs a lot of effort and different operations. The way to reduce the cost is the multi-cluster management framework that I was talking about it, right? That adoption will make your day one and day two operations of any Kubernetes cluster that would help you to accelerate, right? And perform your operations more efficiently, right? And as well as from developer standpoint, that multi-cluster management abstracts all of the Kubernetes complexity and lets you to focus on your business development or business applications logic, rather than getting into the operational perspective of it, right? So adapting a multi-cluster management framework, there are various multi-cluster management framework as an open source product available in the market, and there are various startup ecosystems provides this framework as well, which will help you to reduce your total cost of ownership drastically, right? So either you can adapt a open source upstream product with this multi-cluster management framework that you can deploy it, be it as on the prem as well as on the cloud, and this would help you to reduce your operations as well as brings more developer efficiency as well.